Hello everyone, welcome back. So in this video we are going to understand the Leetcode problem number 27. Okay, so it's the 1727 largest submatrix with the rearrangement. So we'll understand how to implement this type of problem. The problem largest submatrix with rearrangement says that you are given a binary matrix of size m cross n, and you are allowed to rearrange the columns of the matrix in any order. So you have to return the area of largest matrix with matrix, where every matrix of the submatrix is 1 after reordering the column optimally. Okay, so the matrix we have given, let's suppose this, and output getting 4. How you can rearrange the column as shown above. The largest submatrix is 1s in the bold, has area of 4. So if you see this, right, if you rearrange this one, right, so after rearranging, let's suppose this remains same, right, but this get changed, means these values 1 1 1 in the last column will go to the second column, right, and the second column will go to the last column. Understand? Means C3 has been updated by C2. Okay, and so and vice versa. Then if you see, we are getting the submatrix 1 1 1 1, right, like that. It means the largest submatrix of 1s is this, and its area is 4, means 1 1 1 1 like we have, so we can say area is 4. So how we are going to understand, right? This is very important, right? And so very first, let's suppose that, have you ever seen a matrix problem where you are allowed to rearrange the columns? Sounds strange, right? But the small twist completely changes how we solve the problem, right? So instead of, we are going to break down this Leetcode problem of 1727, right, the largest submatrix with the rearrangement. Okay, so I'll show you a powerful trick using the histogram heights that makes this problem surprisingly easy. So we have already talked many times the histogram height side. So in this problem we'll use the same powerful trick, histogram heights, and we'll try to understand. By this end of this video, you will understand the key intuition, the approach, and a Java code implementation. So let's dive in. Also, I'll do another part of this video where we'll do the deep dive session. So if you subscribe my channel, I'll provide the deep dive session in the comment of this video. Okay, so let's try to understand how to implement this type of problem. So let's understand the question first, right? What we have given? We have given this as a binary matrix, meaning all the cells contains either 0 or 1. Okay, so the binary matrix means the matrix contain only two type of integer value, the zeros and the ones. Okay, but our goal is to find the largest rectangle submatrix that consists of 1s. For example, we have this matrix. So this matrix contains all the cells are 1. Okay, our goal is to find the largest rectangle submatrix consisting of only 1s, like this, right? But there is one special rule. What is that rule? So the rule is saying that we are allowed to rearrange the column in each row, right? So let's suppose if we will rearrange the column, right, it means this value will get replaced, or this value can be replaced with any other orders, right? Any other, either this one or this one. Similarly, that we have did with this and this, right, means we have replaced this 0 with this 1. So if you see, the 1 come from here and 0 goes to here, right? Means we are allowed to rearrange the columns in each row, right? Means if we will select this updation into here, right, we have to do the same for these things, right, for these things, right? As we can see in this example, that we have seen that complete these columns has moved to these columns, and these columns has moved to these columns, right? And as you can see here, right, I hope you're understanding, right? That means if we are allowed to rearrange the columns in each row, that means we can change the type of order, right, or the change of order columns, but we cannot change the row themselves. So if this is in this row, it will go in this, like this is in the row, so it will be go in this row only, right? For this one will go in this row only, means this row R1, R0, R1 and R2. So this will never be get changed for any of the cells, right? Means we can change the order of the column, means column can go from C2 to C1, but these values should be remain same. Okay, I hope you're understanding. So this change is used to use this rearrangement to maximize the area of the rectangle made of 1s, right? I hope you're understanding. Let me clean this one. So let's look at this example. Okay, the example what we have given is give me 1 second. The example we have given 1 0, no, we have given 0 0 1, 0 0 1 we have given, right? I'm talking about this example. Then we have given 1 1 1, right? Let's suppose. Then what we have given is 1 0 1. This is what we have given in the example, right? And this is nothing but a matrix like this, right? We have given. Think, okay, we want to find the largest rectangle of 1s after rearranging the columns. But if we try to directly search rectangle, right, the problem becomes very complicated. So instead of we use we should use a very clever trick, right? The idea is to, or the trick is to convert the matrix into heights of consecutive 1s, right? Means we will convert into what? Heights of consecutive 1s. Okay, means we should convert. This is the trick, guys. Okay, means we have given this matrix, right? This is our matrix. So this matrix should be convert into, right, heights of consecutive 1s. If we can do, right, then this will become not complicated, but it's become a clever trick, right? So think of each column as a stack of blocks, right? Like this is the stack of block, this is stack of block, like that you have to think, right? If you think each column, right, each column contains either column 0, column 1, column 2. These columns, if you think as a stack of blocks, if we see 1, right, it means we increase the height plus will do. Okay, if we see 0, means we'll say height reset to 0, height will be 0, like that. Means if we see 1, right, we increase the height like this, let's suppose. If we see 0, means we will reset to 0. Okay, like that we have to think. So let's go with the 1 minus 1 cell. Okay, let me remove this and we can take the reference from here. So the very first row is this row, correct, where what we have 0 0 1, right? So what will be the height? We will say, okay, heights, right? So heights will be what? 0 0 1, no problem, right? Then we'll talk about the row 2, this one, what we have here, and the row 1. So this is row 0, will say, this is row 1. Okay, so row 1 contains 1 1 1 1, right? So the height becomes what? So this time heights become what? Is first it will come 1, then it will come 1, then it will become 2. So it has increased, right? Because the last column has 1 consecutive height, right? If you see, sorry, so what we are trying to say here, that the last column has 2 consecutive 1, means this one and this one, we have 2 consecutive 1. So once we will find 2 consecutive 1, so we will say this will become 2. Okay, then we'll think that what is the next row value will we have, right? So we have 1 0 1. So when it is 101 means we'll say okay, we know that the height should start from where? 2, because previously it was 1, so it had started 1, but now the 2 consecutive 1 came, so we have increased this one also 1. Now this is 2, so we'll start from the 2. Okay, now check, is this consecutive 1? No, so will remain same. 0 is there, so don't do anything, reset to 0. Now again what is coming? 1 is coming, right? So we'll say okay, increase 2 from 3. Like that we will increase. Okay, the very first we have some 0 0 1, so we have kept 1. Now this is 1, and next we have to write what? 1, right? Then we got 1 means 2 consecutive 1 means we have to increase the height. Again we have got the 2, right? So means start with the 2, then we'll reset the 0 because this is 0, right? Then we'll move from 2 to 3 because we got 1 here, right? So it is 3. Like that we'll think and we can implement. Okay guys, so this becomes our height, right? And so each row now represent a histogram of height. Okay, right? So this is called histogram of heights. Okay, this is called histogram of height. So let's try to understand the column rearrangement, right? So here is the most important observation, that because we are allowed to rearrange the column, right? So because we are allowed to rearrange the column, so the order of the column does not matter here. We can simply sort each row, right? Each row based on the height in the decreasing order, right? So what we will do, we'll say okay, for example we have given 1 1 2 we have given, right? So after sorting what will happen, right? After sorting, if we'll talk about this column, what will happen after sorting? It will become 2 1 1, right? So if this is the height we have given, so we'll say like this. Okay, let's keep it like that. So okay, now this will group the tallest column together, which helps to form the largest rectangle. Okay, so if we want to find the if we want to calculate the area, right? How we'll calculate? So we know that the rectangle, right? In the rectangle area is what? Area is height into width. This is the rectangle area, right? For example, what we got from here? We got from here 302. From here what we got? 211. From here what we got? 100. Like that we have got, right? So with respect to this formula, right, if I want to find the possible rectangles, means what will be the rectangle? We'll say rectangle is 3 into 1, 2 into 1, 0 into 3. We can say that these are the possible rectangles we have. Height we have got what? 3 2 0, right? So the here we'll get what? 3 4 0. What is the maximum area? Maximum area is 4, right? So this is the possible rectangle, we can say that, where we got the height is 4, maximum area is 4. That becomes our answer. If you see here, we got our answer, right? So the key idea is we will convert this matrix, right, into consecutive heights, and we'll sort each height, right, for each row, and we'll calculate the rectangles like this, right? And we will using the width simply. So this will work because column order doesn't matter after the rearrangement. Okay, this is what we should implement. Let's go to the code so we'll understand. So as you can see here, right, what are the things we have given? We have given matrix, we have given only, right? So we'll find m and n. Okay, and we know that we need to build the heights, right, for the histogram heights. So we'll build the height like this. We'll get the matrix value and we'll keep adding the value here. then we have to maintain. If the height contains 1, right, it means we will keep increasing the height by 1. Okay, otherwise we will reset the with a 0. So these two things we will do. Then we know that we have to find the area, right? So to find the area, what we need to do, we'll get the row, right, and we'll do the sorting. After sorting, we know that we will find the width first and then the area. So width and area will multiply, right? Sorry, height and width we will multiply, and we'll get the area. To find the max area, we have to track through the max area. So we'll keep a variable, right? And whenever we are going to find all the rectangles, so we have to track this max area value, and we'll return the max area, right? This is very simple. So what we have done till now, we have converted the matrix into these heights, and then for each column, right, we have done the sorting, right? After sorting, what we have done, we have find the area, and we have calculated mainly rectangles. From the many rectangles, we will track the max rectangle, and that we will return, right? So in this case, what are the time complexity will happen? If you see, we have done what, O of 1, right, as a time complexity, and we are also doing here sorting for the all the rows. So in that case, we'll say okay, so the time complexity TC should be O of m will be there, because that will be there, the case will be there, and for the sorting we will n log n, we can say that. Okay, and if you talk about the space complexity, guys, what will happen? We are going for all the test cases, all the rows and columns, right, to store, right? In that case, m cross n will happen. Okay, this is what we need to do. Okay, so other than this approach, if you want, right, what you need to do, that you have to use the brute force approach, where you need to check every rectangles, but complexity becomes very high, because it becomes m square into n square, right, for the time complexity, which is far too slow from this code. So another optimization is counting sort instead of sorting. So since the heights are limited by the number of rows, you can do that. Okay, so that's all I have in this video. So that's the trick that we want to talk, right, behind this problem. And instead of searching the rectangle directly, we have converted the matrix into the histogram heights, and we have rearranged the columns, and we have computed the best possible rectangles. So if this explanation help you to understand the problem clearly, make sure that you like this video, comment if you have any questions, subscribe more for more Leetcode problems and DSA deep dives. So I'll try to cover in another video the deep dive session. Please let me know in the comment section, yes or no. And that's all I have in this video. Please like, subscribe, and share with your friends. If you are struggling with the DSA preparation, you can join our online classes, and for that you have to ping our WhatsApp channel. That's all I have in this video, guys. Thank you so much. Bye bye.